Imagine you're building a city out of Lego bricks, and your task is to create thousands of houses. Instead of painstakingly constructing each house individually, you have a magical assistant named Function. You show him once how to build a house, and from that moment on, he can follow your instructions to build as many houses as you want. The best part? It's as easy as saying, "Function, give me a house," and instantly, a perfectly built house appears. What's more, he's so smart that in more advanced scenarios, he can even learn what elements like windows and doors are. For instance, if you ask him to build a house with large windows and a white door, he can modify the design to match your request, creating something different from all the previous houses that had small windows and brown doors. In Python, a function is a block of code that performs a particular job. Instead of writing the same lines of code over and over again, you can wrap them up inside a function and call it whenever you need it. This makes your code cleaner, easier to read, and much more efficient. For example, if you want to calculate the area of a circle multiple times, you don't need to rewrite the formula each time. You can create a function called calculateArea and let it do the work for you. If you're building a game, you might have a function called movePlayer that handles all the logic for moving a character around the screen. Functions are everywhere in programming because they help us organize our code into manageable pieces. They're like Lego bricks, you can snap them together to build something bigger and more complex. The beauty of functions is that once you define them, you don't need to worry about how they work internally. You just trust that they'll do their job when you call them. This is called abstraction, and it's one of the most powerful ideas in programming. Now that we understand what functions are, let's talk about why they're so important in programming. Imagine you're building a house. You wouldn't try to construct the entire house in one go. You'd break the project into smaller, more manageable tasks like laying the foundation, building the walls, and installing the roof. Functions work in the same way. They allow you to divide complex problems into smaller, easier-to-handle pieces. This makes your code more organized, efficient, and easier to troubleshoot. After all, programming is all about solving problems, and functions help you tackle each piece one step at a time. Now that we understand why functions are useful, let's take a closer look at how they're built. Just like a recipe has specific steps, a Python function has a specific structure. Once you understand the structure, writing functions will feel like second nature. Here's the basic anatomy of a Python function. Let's break this down step by step. The def keyword. Every function starts with the keyword def, which stands for define. It tells Python, "Hey, I'm about to define a new function." Without def, Python wouldn't know that you're creating a function. Function name. The name of the function should describe what it does. Good function names are like good labels. They make your code easier to understand. Avoid vague names like doStuff or function1. Instead, aim for clarity, like calculateArea, find largest number, or greet user. Parameters or inputs. Parameters are like ingredients in a recipe. They're the inputs your function needs to do its job. The return statement is how a function sends back its result. Now that we understand the syntax of a function, let's build a simple one together, a function that calculates the area of a circle. If you're feeling confident, take a moment to try it on your own first. Here's a simple way to do it. We start with the def keyword because we need to define the function and let Python know what we're doing. Next, we choose a name for our function. Let's call it calculateArea. Inside the parentheses, we add parameters, and in this case, we need radius because we can't calculate the area without it. Plus, we want it to be different each time we call the function. In the return block, we specify what we want our function to return. In other words, this is where the math happens. We'll use the formula for the area of a circle, pi multiplied by the radius raised to the power of 2. Finally, to call our function, we use it inside a print function and provide a value for the radius to get the result. Since we're already doing some math, how about we try another function, this time with 2 parameters? Let's go ahead and calculate the area of a rectangle. As before, we start with a keyword def, followed by a descriptive name for the function. Let's call it calculateRectangleArea. Inside the parentheses, we list the parameters. Since we're calculating the area of a rectangle, we need both length and width as parameters, separated by a comma. These are essential for the calculation. In the return block, we use the formula for the rectangle's area, length multiplied by width. To test our function, we can call it with two values. Let's use 4 and 6 for the length and width, respectively. After trying out these examples, you should get a feel for how to write functions in Python. However, there are a few important things to keep in mind. First, you can always store the result of the function in a variable. This way, you can either call the variable directly or use the function again later. Second, the return statement is not always necessary. The program will still run even if your function doesn't have one. For example, let's say you create a simple function called sayHello that just prints a message but doesn't return anything. If you try to store the result of sayHello in a variable, it will be none because the function doesn't return a value. Lastly, indentation is crucial in Python. The lines inside the function must be indented properly so that Python knows which lines belong to the function. And here's a key point. You can include multiple lines of code in the function body if the task requires it. For example, you might add error handling or print messages to guide the user. Now, let's dive into something important: keyword arguments versus positional arguments. When you call a function, you can pass values, arguments, in two different ways, by position or by keyword. Until now, we used positional arguments because it's the most common way to pass values to a function. The values are assigned to parameters based on their position in the function call. In other words, the first value goes to the first parameter, the second value goes to the second parameter, and so on. Here's an example. In this case, Alice gets assigned to name and 25 goes to age because of their positions in the function call. The keyword arguments, on the other hand, allow you to pass values by explicitly naming the parameters. This means you don't have to worry about the order of the parameters. Just name them and give them the values. Here's an example. When we call the function, we are not just passing the values, but explicitly using their names and assigning values with an equal sign. By doing this, even though the order is reversed, Python knows which value goes to which parameter because we've used their names. This is especially useful when functions have many parameters, as it makes the code more readable and avoids confusion. Why use keyword arguments? Flexibility. You can pass the arguments in any order. Readability. It's clearer what each argument represents, especially when working with functions that have many parameters. Default values. When a function has default values, you can skip the arguments that don't need to be modified. You can also mix positional and keyword arguments. However, the rule is that positional arguments must come before keyword arguments. Here's an example. In this case, we used positional arguments for name and age and a keyword argument for country. It's totally fine, as long as the positional ones come first. Sometimes, you may need to define a function inside another function. This is called a nested function, and it's useful when you have a function that doesn't need to be called outside of the function it's defined in. Nested functions are helpful when you want to organize your code better by keeping related logic together. You want to limit the scope of a function so it doesn't interfere with other parts of your program. You need a function that is only relevant within another function and shouldn't be used independently. In Python, a nested function is simply a function defined inside another function. The inner function can access variables from the outer function, which is known as lexical scoping. Here's an example. In this example, inner function is defined inside outer function. When we call outer function, it also calls the inner function inside it. The inner function can access variables from the outer function. This is especially useful when you want to use the outer function's variables without passing them explicitly to the inner function. For example, here, inner function can access x from the outer function and print its value. Even more, you can also return the inner function from the outer function. This is useful for creating function generators or more complex behaviors. For example, in this case, the outer function returns inner function, which can then be called later with access to the variable x. Summary. Nested functions allow you to define one function inside another. The inner function has access to the variables of the outer function. They're useful for organizing code and limiting the scope of functions. You can return the inner function from the outer function for more flexibility. A lambda function is a small, one-line function that you can create without using the def keyword. It's called anonymous because it doesn't have a name, and it's usually used for simple operations that don't require a full function definition. Here is the syntax for a lambda function, where lambda is the keyword that indicates you're creating a lambda function. Arguments are the input, like the parameters in regular functions. And expression is the single operation or computation that the function performs. In this case, lambda creates a function that adds a and b. We assigned it to the variable add, so now we can call it like a regular function. Why to use lambda functions? Conciseness. Lambda functions are great for short, simple operations that you don't need to reuse elsewhere. Readability. They can make the code more compact and easier to understand, especially when used in situations like sorting or filtering lists. No need for definition. If you just need a quick function for a small task, lambda functions save you from defining a full function with def. Limitations of lambda functions. Single expression. Lambda functions can only have one expression. They can't have multiple statements or complex logic like regular functions defined with def. Not as readable for complex tasks. If the operation is too complicated, it's better to use a regular function. But this is not all. Even tough simple, lambda functions are often used with Python's built-in functions like map, filter, and sorted. Since these topics are a bit more advanced, we will cover them next week. For now, we'll keep things simple until we get more comfortable with the basics.